answer isn't that much of a challenge if you still remember your point slice shape.
Yes, I know.
Okay, it's just another way of writing your graphical equation. Alright? So we're going to look at parabolas and circles in this chapter 9. Okay, a break away from our differentiation first before we jump back into doing integration. Okay, so what exactly is a parabola? Okay, basically a parabola is something like that. Okay, so it is like your quadratic curve, but it is on the sideways. Okay, so your axis still remains the same, x and y. Okay, so this is a graph of a y square equals to kx. Okay, so in this particular case, we find that our k must be more than 0. Okay, which is sensible because if our x values are going to be positive, okay, we find that your y values are positive and also negative. So your k must be more than 0 in order to allow us to have your y square equals to kx. Okay, so this is the equation for a parabola. Okay, then after that, likewise, if we flip it to the other way, the equation remains the same, just that it's k less than 0. Okay. So previously when we studied our quadratic curve, our y equals to ax squared. Okay, just that in this case it is like a change in variable. Okay, therefore the change in the shape of the curve. Okay. So some symmetrical properties when it comes to, or rather some properties when it comes to a parabola curve. Okay, so you will find that they are symmetrical. Symmetrical about where? In this case, sorry, my sketch may not be very accurate. Okay, it will be symmetrical about the x-axis, not the y-axis. Okay.
So it's chapter 9.1, right?
Yes, in chapter 9.1. Okay, and then likewise also with this equation, when x is equals to 0, y will actually be equal to 0 as well. So it passes through the origin. Okay. Yeah, so whenever the equation is like this, it will surely pass through the origin. Okay. You cannot plus or minus constant. Plus or minus constant will surely allow it to only shift up and down. Okay, it doesn't allow it to shift left and right. Okay, but we're not going to explore what is it that will cause the graph to shift left and right. Okay, so at this point, we are not going to explore that. But if you're interested too, okay, I'm not stopping you. You can go back home and explore. Okay. So if I have a curve that's, for example, y squared equals to kx, and then I also have another curve x squared equals to ky. Okay, or in other words, this is like a quadratic curve, y equals to 1 over kx squared. Okay, if the value of the k is actually exactly the same, we will find that they are actually symmetrical about a certain x, not about the axis, but about a line. Okay. Okay, it will be about this line, y equals to k. Okay, sorry, not y equals to k. Y equals to x. Okay, so when it comes to this topic, okay, one of the things that you need to do is definitely the sketching part. Okay, you definitely need to know how to sketch these graphs. Right? Then after that, when it comes to problem solving, okay, it's not much of difference from doing your point science shape, okay, whereby we have to do a lot of simultaneous equations and so on.
Point what?
Point science shape, your chapter 6 from last year. Okay, let's look at try 2. In the diagram, the curve y equals to x squared meets the line y equals to 3x plus 4. So we draw the line. Okay, so they meet at the points A and B. So this is A, this is B. Okay, and then the straight line actually cuts the y-axis at the point M. So in part 1, we want to find out what's the coordinates of A and B. Okay, so this one is fairly simple, right? Are we all familiar how to do? How do we do it? Just do substitution, right? So therefore the coordinates would be 416 and negative 1, 1. If accurately marking out the A and B, A would have to be 416 and B would be negative 1, 1. Right? Yeah.
Use the y equals x squared instead of this. It's easier, right?
Oh, yeah, can. Okay, then after that in part 2, we want to find the ratio of AM is to BM. Okay, how should we go about doing that? We have already found the coordinates. Let me just put that in. Negative 1, 1. And then this is 416.
Just use length of line segment.
Sorry?
Length of line segment.
Length of line segment. Do we know the coordinates of M?
Sub n equals 0.
Okay. So we can sub in x equals to 0 into the equation of line, find the coordinates of M. Okay, what else could we do? Is there an alternative method? Other than using length of line segment. So method 1, length of line segment.
Similar figures you can see at the top.
Can just
Okay.
use the
Huh? Okay, similar triangles.
How do you see a similar?
How do we see a similar triangle? Okay, so you could actually see that we have A to M can have a right angle triangle, and then after that B to M, a right angle triangle. Okay, they will have to be similar. Alright, these two angles will definitely have to be the same, these will have to be the same, because corresponding angles. You see that? Because these are all vertical lines and horizontal lines. Okay, so they will be parallel, so therefore corresponding angles will tell us that these two triangles that I've drawn, they will have to be similar. Okay, so by similar triangles property, okay, that might actually be easier than having to go about finding the length of the line segment. Okay, because it might not always be the case where you are able to find out what is the coordinates of M. Right? So in this case, if you were to look at method 2, okay, we want to find AM over MB, right? Okay, so for this ratio, it will be actually the same as if I were to maybe let me label this as C and B. Okay, it will be the same as AC over MB. Okay, as well as the same as CM over DB. Right? Anybody not following? Okay, so therefore, in order to find out what is AM over MB, we could find out what is the value of any of these two. Okay, which is fairly simple, right? Because if I were to find out what is AC over MB, which is the vertical heights, okay, so A has the coordinates of 416, okay, so that means that this will actually be 16 over here, okay, and then after that we also need to find the coordinate, we also need to find coordinates of
CM and DB. Because you just got 16 and 1.
CM,
Then DB.
DB.
1 and 16. Divided by the 4 and 5.
Oh, okay, okay. If we want to skip having to find out what is M, okay, we can use CM over DB. Since they are all relative to the origin itself, so C over here will be 4, and this will actually be negative 1. So CM will actually be 4 units, and then after that, DD will be 1 unit, right? So therefore, AM to MB will be 4 is to 1. Do you all follow? Any questions? Yep. Okay. Okay, part 1 in try 3, likewise we want to find out what are the coordinates of A and B. So we will do substitution as well. So we can find out what is the coordinate of AM. Okay. How do we find the equation of the perpendicular bisector of AB? What are the things that we need?
Gradient.
We need gradient, okay, gradient of AB.
The point. Midpoint. The midpoint.
Okay. So the gradient of AB is 1. Is that sufficient for us to find out what's the equation of? Okay, we need to find the equation of perpendicular bisector. So the gradient of perpendicular bisector be equals to the negative reciprocal, so that will be negative 1 in this case. Okay, then after that we need to find the midpoint. That will be 2, 7. Okay, so the equation will be y minus 7 equals to negative 1 times x minus 2. So therefore, the equation of the perpendicular bisector will be y equals to negative x plus 9. Could I erase try to? Erase up. By the way, your 10-year series has already arrived, right? I have asked Jin Xiang to get some of the people in class to actually go and pick it up from the school bookshop, right? Okay, next part. Okay, the question says that another line which is parallel to y equals to x plus 5 cuts the curve. Okay, the one that's given only at the point C. So another line parallel to y equals to x plus 5 cuts this thing at C. Okay, and then we want to find the coordinates of C. Right? How do we find the coordinates of C? How do we find the coordinates of C?
So is parallel only cut at 2 points.
Maybe, maybe not.
So we
Maybe
cut
just
the
one
minimum point.
Huh?
Cut the minimum point.
Why must it be a minimum point? Must it be a minimum point? Cuts only at the point. Maybe let me emphasize. Cuts only at C. Will this parallel line actually cut the minimum point? Must it cut the minimum point?
Oh, no, that's just like
If it cuts the minimum point, then what should the gradient actually be? 0. Then will it still be parallel to y equals x plus 5? No, right? So it will just be a what kind of line? A tangent line, right? So since it only cuts at 1 point, so it will just be a tangent line. Sorry, my line. Okay. So don't always assume that it cuts the minimum point, right? So, but then, okay, knowing all this, then what can we do? How do we find the coordinates of C?
Depreciation.
Yeah, depreciation. Get the gradient, okay, the gradient will be
1.
of line will be 1, since it's parallel, right? Then fine.
Divide dx is chapter 9.1.
Okay, let's you can do dy dx. Okay, I did do a method dy over dx. Okay, let's do a dy over dx. Okay, so because we agree that it's tangent, right? Okay, we agree that it's a tangent, right?
You can also use area with E map.
Okay.
You can use shoelace in E map.
dy over dx, then what?
Then this is the gradient.
This is the gradient, so x minus 3 equals to 1.
X equals to 4.
So x equals to 2, right? So what can we interpret from this x equals to 2?
Then so you sub
It's more than 2, so it's
Okay, so we sub this into where?
the Y equals to x plus 5.
X squared minus
Y equals x plus 5.
X squared minus 3x.
X squared minus 3x, right? Because this one is the y with gradient 1.
So it's y equals 2 also.
Okay? And then we're trying to find out what's the coordinates over here. Correct? So this is x equals to 2. So we're supposed to sub in into the curve equation. So that will be 2 squared minus 3 times 2. So that will be negative 2. Right? Okay? So we then now have the point, the coordinates of C, which is actually 2, negative 2.
So we then we don't know differentiation now.
Wait. Okay, we get the coordinates 2, negative 2. So now if we don't know differentiation, how?
We know it's a tangent.
Then
we give up.
So why check ourselves?
By the way, this is not wrong, you will not be marked wrong. Okay? Just that what will be another alternative? We know that the gradient of line is equals to 1, then gradient. Okay, can we form maybe the equation of the line first?
Y equals to x, then also the constant.
Okay, the equation of line will be maybe y equals x plus c, correct? For some constant c, right? Okay, we do not know what is the coordinates yet. Okay, but we know that this line will definitely intersect with the curve, isn't it? So therefore, okay, they will substitute one another, correct? Because they are going to intersect with each other. So I can after that have a equation that looks like this. But what can we make sense out of this equation?
Wait, actually.
How?
So
Any idea? Huh? Discriminant. Okay, good. Alright? Because we know that it is a tangent, touches one line, one point. Okay, so we can interpret the discriminant out of this equation. Okay, so the discriminant.
thank God we learned differentiation.
Oh my
It touches at
god.
1 point, so equal to 0.
Okay, so 16 plus 4c.
Equal to 0.
Then because we know that it is a tangent, so this discriminant will have to be equals to 0.
Oh my god.
Wow, okay, cool.
So your constant will have to be negative 4. Okay, so therefore
Y equals x minus 4.
your equation will be y equals to x minus 4.
So just use dy dx.
Just do dx.
Okay, then after that, wait, I've lost track of my thoughts.
So then sub into the real equation.
Okay, why do I have this? Okay, so I know c equals to negative 4, so I sub this back in. Because I want to find the coordinates of c, right? Okay, so I sub this back into here. So when c equals to negative 4, x squared minus 4x minus negative 4 will be equals to 0. So x squared minus 4x plus 4 equals to 0. That will be x minus 2 bracket square equals to 0. So therefore x is equals to 2. Okay, then after that we can find out what is y, which will be 2 square minus 3 bracket 2 still. So that will actually still be negative 2. Okay, so both methods are acceptable, right? But you cannot actually only focus on one and then forget the other. Okay, because surely discriminant will still be tested, yeah?
So discriminant.
Will they ask you use discriminant?
It won't tell you that. Yeah.
So but every time you use discriminant to find out points intersect.
Yeah?
It's like
You do this in discriminant also what? Chapter 1 we also do this, remember? Okay, Teresa said that is when you're dumb and don't know differentiation. They say that.
Rachel?
Yeah.
I don't know how to do it.
Okay, then after let's move on to the last part. I think it's part 4, right? Part 4 say hence find the area of the triangle ABC. So C is here, right? So we want to find the area of this triangle. Okay. In this case, what kind of methods will you employ? Shoelace, right? Okay. 1/2 times base times height is fine. Just make sure you know your length formula correctly. Okay. So area equals half, and then after that, A we have found it to be -1/4. Go in a what kind of manner? Anti-clockwise. So next coordinate should be C. 2, -2, 5, 10, -1/4. Okay, I leave the working to you. Alright? You all remember? Okay, -1 times -2 plus 2 times 10. I think I better write down.
So it's 22.
-1 times -2 plus 2 times 10 plus 5 times 4 minus away 2 times 4 plus 5 times -2 plus -1 times 10. Okay, and that will give you 27 units square. Just remember to write unit square. Okay, any questions? Okay, so slowly we are bringing back everything that we have studied last year. Okay, let's just do one last two question for this unit. Our lesson end at 4, right? Yeah. Huh? 27, right? Yeah, we check.
I couldn't understand that back then. When you said set 3 and set 4 is very cool. Then when I was in set 2, I was like, set 2 and set 3.
Okay, so in this case, we are given a parabola y squared equals to 3x. Okay, then after that, we are told that it means the line y equals 6 minus x at the points A and B. Okay, we want to first find out what are the coordinates of A and B. Okay, could you all very quickly find out what are the coordinates of A and B?
Watch the video.
I want to do it.
Yeah, 437.
I don't know. I think so. I think there are sometimes quite recorded, right? I didn't do record before. Is it captured?
No. I just captured the board.
Okay, shall we have fun? And then increase the viewership. Sometimes you just click on video and then you show exit the audience. So must take already watch more.
I'm not trying to be a YouTuber.
What do you mean the
So you can what if you have enough subscribers.
There are we consider moonlighting and then the principal start looking for me.